let's begin. So I'm just gonna pour what I gave you guys yesterday as your unknown into that jar. So that way we can go through the process like you guys did. All right, so first thing we want to do is write what we are trying to identify. Where's all my markers go in there? Okay. We need a blue marker, we need a green marker, we need a red marker, we need probably a black, maybe an orange marker. Where's my black marker on? There it is. Okay. Cool. All right, so this unknown ion that we are identifying for is our unknown cation number 1. Hopefully you guys have that written down. This is the first one I gave you. This is also the one I'm going to use as my teacher example. Cool. All right, so we are pretending this is exactly the same way that you guys did it yesterday, so you guys can see the thought process and what we are doing. So I have my unknown right here, unknown number 1, which is what you guys had yesterday. And if we look at our flow charts, let me just grab that one. We want, that's the flow chart. Okay, so just as a reminder, I said we are identifying the cation, so we're not using this one here. We are using this one over here. Some of you guys started on the wrong flow chart because you were just doing what we did last week and totally forgot the first instruction of we are identifying the cation. All right, first step in that one is to take my unknown and add 2 drops of dilute sodium hydroxide. So I'm going to write that down as my first step. That's an achieve requirement. Unknown. Plus 2 drops of NaOH. Cool? All right, let's do that. So here's my unknown. Getting a little bit of it. Now, one thing you're going to have to learn about this standard is that you're just having to make sure we get the ratios really right. I just added a little bit in there. If you guys can see, there's not much. All right? The reason why is because if I have a complex ion that forms, I don't want to have heaps and heaps and heaps of the precipitate to try to dissolve later. All right, so I'm looking for my sodium hydroxide, which hopefully is still in this box because you guys hopefully put everything back in the right spot. It's 2 sulfuric acids in there and no sodium hydroxide. Someone really mucked up my box here. It's 2 sulfuric acids in here and no sodium hydroxide. This one has no sodium hydroxide either. What are you guys doing? There we go. Might need to restock our boxes. Okay, so add 2 drops, 1, 2, and I can see a white precipitate forming. It's kind of like a jelly-like one. Yeah, agreed? Okay, so observations, I write down white precipitate forms, or you go white PPT forms. Can I just write PPT forms, precipitate forms? No, because I need to specify the color, because when we look at that flow chart, there are lots of different colors. White, green, orange, blue, brown. That's going to influence where I go down the flow chart, isn't it? So I need to specify what color it is. Okay, after I've done that, the next step is add excess sodium hydroxide. So let's go back to our sheet. Let's write that down. We're going to add excess NaOH to the sample. Again, this is why the ratios are important. So I'm looking at this thing right here. I can see there's some white globs. I'm going to add excess, shake it up real good, and I notice that it's now gone. Or even if it's not all gone, if it's starting to dissolve, then count it as dissolved. If you guys are not sure and you want to double and triple check, remember I'm happy to give you bottles with the actual known ions in there. So if you want to go, ooh, I'm not sure if it's actually dissolving, and we go back to our flow chart and like, ooh, I want to just make sure that it's not magnesium or barium, I'm happy to give you magnesium and barium so you can see what they look like in comparison, okay? So from that information, I'm going down this way. Let's go back to our sheet here. So we have white precipitate disappears. Now I'm actually waiting to write my justifications and my equations because I personally like to wait to know what I have so that way I can then integrate in the solubility rules as I need. You don't have to do it in that order. You can write your justifications as you go. So for example, justification of step number 1, a white precipitate forms, then that means I narrow it down between my list because it has to be, those are the only white precipitates. So if we want, we can put that down. So justification since a white, actually we should do it while we're working. What was the other one? Aluminium, lead, or zinc. So that's how I would justify it there. Remember, the justifications are what you need for your merit. Are we okay with that? All right, we could also justify step number 2. So we know that the precipitate disappears. Why did the precipitate disappear? Why did precipitate disappear? Complex ions formed, all right? Which are soluble. Cannot be what? Barium or magnesium. Why? Because they don't form complex ions. So what is our choices? Could be what? Now I'm running out of space. Aluminium, zinc, or lead. Running out a bit of space there. I might have to change the sizing so that way we have more space for justification, less space for equations. It's a work in progress. Okay, cool. Are we okay with that so far? Okay. Next thing then on our flow chart is 2. It disappears. So we have aluminium, zinc, or lead. We have a new sample. So new sample means I do what? Wash it out. Get rid of that. Get rid of that. There we go. All right. So we take, again, a little bit of our sample. And we add 2 drops of ammonia and then excess. Now, I don't like how this flow chart is designed because it doesn't treat it like 2 separate steps, and I would personally treat it as 2 separate steps. So back to this guy here. Back to adding a little squirt of that. All right, and then find our ammonia, which is normally in the bigger bottle. We add 2 drops. Now this might be a ratio game that you have to play. You might need to add a little bit more ammonia and a little bit more of the unknown until you get your precipitate forming because you have to get the right ratio. So don't be surprised if you need to play with this a bit. You might also need some stronger ammonia, which this might not actually be good ammonia. Problem with it is that it's not always, you guys used a lot yesterday. A lot of problem solving that you guys are gonna have to do. This is why I give you guys the known solutions, right? That way you can use it as backup. I might start over, see if you get more luck. Unknown. And again, we gotta play with it, right? Because if we overdo it, then we're gonna think it's zinc. How many people thought it was zinc yesterday? A lot of people. That's why we gotta test it out a couple times. Now, why is this not precipitating the way I want it to? I don't know. It should. I didn't give you guys zinc yesterday, and I currently don't have zinc right now. Why aren't you forming a precipitate? Oh, I can see why you guys misidentified it now. Adding quite a bit of ammonia to see if I get it precipitating. Oh, that is weird. It's not working. What are you doing? Oh. That is weird. Something's going wrong with this. Just gonna pause the recording while I figure this out. It's okay. I'm ready. Okay. So, unfortunately for us, the aluminium, when it makes its complex, or not complex, when it does the precipitation reaction with the ammonia, is not that obvious. You probably won't be able to see it under the document camera, but I'll pass this around. It's kind of like this weird jelly. It's still the same white precipitate that formed before, but I think it's useful to kind of see in comparison. So when you had lead, now I gotta find my lead. So here's lead. That was not a clean beaker. Rinse that out again. All right. So this is why I want you guys to ask me for known ions if you're having a hard time distinguishing between the three of them, because the white ions are very similar. Or I should say the lead, the aluminium, and the zinc are very similar. So the aluminium one, unfortunately, kind of doesn't really produce anything that's really obvious. It's kind of more like a jelly-like texture, which is hard to kind of see. When you do the lead with the ammonia, did I not? Why is it still not clean? Okay. All right. When you do the lead with the ammonia, you should get a white precipitate. Now, I've picked up a more concentrated ammonia just to make sure that it works. So we just do a little bit of a squirt. And you should get, there you go, white precipitate forming. Again, they're all kind of like white jellies. Yeah? Not terribly helpful. If I added excess on there, it shouldn't get any dissolving. It just becomes more white. So that one's lead. And then I'll just dump this out so you can see what zinc looks like. So I'm grabbing zinc now. Zinc. I'm putting that in here. And then here's my ammonia. So again, just trying to put a few drops on there. And it also has like that white kind of jelly-like thing. You kind of see it when I concentrate it over there. Are we okay? So they're all kind of similar, and they're all kind of hard to tell apart. Lead obviously is a little bit easier because it's quite dark. But the zinc and aluminium are both kind of similar in a sense that they make a kind of a jelly-like thing. I'll pass around aluminium so you guys can have a look at what I'm talking about. It's a hard one to pick out. But with the zinc, if it is zinc over aluminium, it will dissolve. So if I add excess, and I add lots of ammonia to it, hopefully it dissolves eventually. Well, now I've managed to see. So that's the zinc ion with it. And now I'm just going to squish a lot of ammonia in there, so hopefully it dissolves with time. All right, not really dissolving yet. So what I'm going to do then, if I get in this situation, is I'm going to take another beaker. I'm going to rinse this one out. So do you remember how I said sometimes you can get into this problem where you don't get the ratios quite right? And then the ion stays there? Grab another pipette. Take a small amount out so that way you can play with the ratios. Put it into the next beaker. You can still see the precipitates there. And then hopefully now you can get your ratios right so that way it dissolves. See? So it's just a matter of getting the ratios right. Do you want me to do it again? All right, this is my zinc that I've taken out from the previous beaker. I'm adding into this beaker so I can get my ratios right. and I can see if it's dissolving or not, which it is. Okay? I might need some more ammonia now. There you go. Doesn't need to fully dissolve, just needs to kind of dissolve. Sorry, I'm not explaining this very well. Ion identification can be hard. All right. So, chemistry is a pain in the butt. Nadir hasn't seen it. All right, so what that step tells me, the white precipitate disappears. We added the 2 drops, and then we added excess, so let's add those 2 extra steps now. So, we did new sample. We did 2 drops of, we did unknown plus 2 drops of ammonia. And we saw, wasn't great, but there was a white precipitate. You can write a white gel precipitate. In the 4th step, what did we do? We added excess. Bathroom? Yep. Let me get a note. What's the date? There you go. All right, so we added unknown 2 drops of ammonia, and then we added excess. And we should have that the precipitate remained. I keep playing with that. So it should form and then stay. I don't know why I'm not getting that. All right, so when we are thinking about our justification steps, just trying to see if I can get it actually forming. Really doesn't like it. All right, thinking about our justification steps. So since we actually could probably combine steps 3 and 4 together. So, white PPT formed and then remained. So, unknown cation. Cannot be zinc because it can form a complex ion with ammonia and thus will be soluble. So it's either zinc or lead. Sorry, aluminum or lead. Good catch. All right, are we okay with that? Just be mindful, I kind of misdid the colors here. The stuff with the complex ion, that is the excellence level stuff. So that's just a mistake over there. That's excellence. Cool. All right, next step on the flow chart then, when we're looking at it, it says, white precipitate forms and disappears, it is zinc. If a white precipitate forms and remains, then we have aluminum or lead, and we get a new sample. So once again, we're taking that out. And what we're doing is we're adding the sulfuric acid. So we take our unknown, we add sulfuric acid, and we should not get a precipitate because we are dealing with aluminium. So that's going there. And then now I gotta find my sulfuric acid, which is over here. We add 2 drops, just a few drops actually. Look at it, not forming anything. If I want as a reference point to see what lead would look like, I can grab another beaker. Just gonna get a mess of beakers right now. It's gonna be fun to clean up. All right. If you want to compare to double check, I can happily give you a lead so you know what lead looks like. That is lead. And then if I added sulfuric acid to lead, it's a pretty obvious white precipitate. So we can be pretty confident that's not lead. All right, so we did a new sample. We did unknown plus sulfuric acid, and we saw no precipitation. So based off of that information on the flow chart, I have aluminium. All right, and then bottom bit here, justification. So I need to think about why do I know that it's aluminium and not lead. So the rules for our solubility rules, if we look at it, we can see that we have most sulfates are soluble with the exception of calcium, barium, and lead sulfate. So I have now eliminated lead as a possibility. So has to be aluminium because if it was Pb 2 plus, white PPT would have formed. All sulfates are soluble. Yep. Except lead sulfate, if you want to write that down there. So that's why lead is going to form a precipitate, whereas aluminium will not. Cool. All right. If you handed this in, will you pass? No, because what have you not done? Precipitations and equations. All right, remember, when we're trying to figure out our precipitations, we are thinking about what we've identified and what we have added. So if I added aluminium and, sorry, if I have aluminium and I added sodium hydroxide, I have aluminium hydroxide. If we are worried that we are going to make a mistake with the formula, what should you do? Write it down in the word form. Now I gotta figure out how to spell aluminium. A-L-U-N-E. I'm just gonna Google it. Because let's face it, Miss cannot spell. I can type it. That's weird. I can write it, but I can't like write it. Anyway, aluminium hydroxide is up there. All right, aluminium hydroxide. Excess white precipitate disappears. Do I need to write anything here? No. This one, new sample, white precipitate forms. What is it? Aluminium hydroxide again. Why? The hydroxide is a weak, or sorry, the ammonia is a weak base, providing hydroxide ions. All right, anything here? Nope. White precipitate remains. Anything here? Nope. No precipitate forms. All right. Equations time. So what I suggest you guys do is start with the final product, work your way backwards. Do not include spectator ions because you then have to balance them. If you don't balance them, you don't get merit. Let's forget about them. All right. We have Al, close brackets, OH3. That is your solid. And then backtrack Al3 plus 3OH minus. These are both aqueous. You don't need to write down the states in the equation, but it does give me another chance in case you make a mistake. And if you want, you could also write down that you know that this is white. Again, just gives you another chance. All right, next one, complex ion. We are going to find that based off of our list. Back in the day, we did not give you this list, so feel very grateful that you are getting this list. If I'm looking at this list here, I'm looking for the one with aluminium. It is this guy over here. So I will write down on my piece of paper, Al, close bracket, OH. We have 4 of them. We got a square bracket, and we are doing a minus sign, and I think that's it. And this is now aqueous. Yes. Oh, thank you. Can you please place it over there? Because I'm currently like, got chemicals on my desk. Thank you, though. All right, are we okay? All right, keep going. All right, third step here, we had to precipitate. Which one's what? Aluminum hydroxide. So again, we write the same equation again. That's solid, that is white. And then we backtrack. Al3 plus 3 that, aqueous, aqueous. Do I have to write an equation for number 5? Or number 4? Yes or no? No, because number 4 was just the white precipitate remains, so you don't need to write a new one. And then number 5, we had no precipitate, so you don't have to write an equation. Are we good? All right, we end at 25, don't we? All right, let me go back and show you the marking criteria, just to remind you guys. So remember that we are only looking at 1/2 of our ionic compound. You will need to also figure out the anion as well to get marked. If you do not correctly identify the ionic compound, it is automatic, not achieved. This is an achieve requirement over here. Right there, right there. So if you misidentified it as zinc yesterday, you would have gotten an unachieved on that question. All right, steps and procedures, observations, all precipitates. This one you'll do later. So that's tick, tick, tick. We got all that done for our cation. Link your procedure and observations to the flow chart and solubility rules. So talk about white precipitate. I know it's these potential options. I know this is the precipitate because of solubility rules, etc., etc. This one here, write down all your equations, and you only have to do this for 2 of the ions. So I do allow you a chance to make some mistakes by the looks of it. This one here is comprehensively link the procedure and observations to the flow chart, solubility rules, and complex ions. So talking about that complex ion section is really the key in that one. Cool. All right, questions, concerns, or comments? I know that wasn't one of my better lessons, not gonna lie. All right, what else did I have to say about that? Oh, the last thing I want to say is that we are going to do best out of 2. So I will give you 1 ionic compound. You will do the whole practical. I will mark it. I will give you the feedback. And if you are happy with that grade, you can go ahead and start writing your essay. If you are not happy with that grade, you then go on to ion number 2. All right, and you identify ionic compound number 2. Depending on which of these 2 is the higher grade, you then can go on to write your impact essay, not even essay, statement on whichever one it is. You have to pass both the practical and the written component of it. So this, how does it affect humans? How does it affect the environment? All right, cool, that's us.